I have 3 votes. 3 votes so far. 4. But the first 2 were boys. Why is this one still 50%?
But they're family.
So these are all independent events?
Yes.
And the odds of something that's 50-50, if it's an independent event, is always going to be 50-50, right?
Yes.
The next person in line, a friend of mine, Emma. Don't know what she's having. What are her odds of a boy?
50.
We're missing one person here because she had to go to the bathroom. Go figure. Tell pregnant women to line up and somebody's got to go pee. That being true, what's the probability of her having a girl?
50.
She is having a girl, so we already know that. It's a girl. These 2, they're not far enough along for us to know anyway, so. So you understand when something is 50-50, it's always 50-50. Have you ever then used the term more random?
Yes.
Can things mathematically be more random? If something is random, can something else be more random? Mathematically, there is no such thing as more random. And I say this because radioactive decay, whether or not a particular atom is going to decay, a radioactive one, is random. It is never going to be more random or less random than another atom that is radioactive that is next to. So as we go through some of these, I just wanted to caution you in advance that we don't use the terms more random or less random. And we don't get bamboozled, because things that are 50-50 are always 50-50. Now, had I changed the question and made each of these events dependent upon each other, then we would have had to do some pretty fancy math. Like, what is the probability that all 3 women who are the first to deliver will have boys? That's a different question, right? So we have to be careful when we think about these kinds of questions. Now here's where I tap skills. Ready for this? With your partners, graph, God bless you, graph the following equation.
Mr. Brown.
Show me your graphs. That's a miracle if they hit the floor and they didn't break.
They did it. Thank you.
Suitably warned. Not going to be beautiful. I do not. I stepped back from it so I could take some classes, but I never learned how to throw because you don't really throw in golf. It's not really one of those skills they use. If you're throwing in golf, something went wrong.
Oh, yeah.
The graph you should have made should resemble this. What this graph actually tells us is the percent that remains of any decaying sample that decays at a even constant rate. The even constant rate that we're looking at here is 1/2, right? That's what we said. When we look at radioactive things, we always look at how long it takes for 1/2 of a sample to decay. That's why we started with the fraction 1/2. Following? You with me so far?
Yeah.
Everybody with me so far? Okay. So if I start with a brand new sample, it's a new sample, no time has passed. No time has passed is equal to what number passing? 0. If no time has passed, how much of my radioactive sample remains in a percent?
All of it.
All of it. What's all of it? 100%. So at time 0, 100% of the remaining particles are radioactive, right? At time 1, we said we count time based on how long it takes for half the sample to decay. So how much sample will remain? 1/2, which is the same as what percent? At time 2, half of the remaining radioactive atoms have decayed. What percent of the original remains? Mhm. Now some of you are like, but I thought after this amount of time, after 1 to 2 is only one length of time, right? Half of it decayed. Half of the remaining half decayed. Half of a half is 1/4, right? At time 3, what would remain? That's all this graph actually tells us. If we look at the graph that we've made, we can say at time 0, I have 100% of the radioactive sample remaining. You agree? At time 1, I have 50% remaining. At time 2, I have 25% remaining. No matter what radioactive isotope you look at, it could be thorium, iodine, technetium, carbon, anything that's radioactive, this graph is true every single time. So there's only one equation to know. The only equation to know is that one. And all we have to do, if I say after 1 half-life, then you would just put 1 in for x, and you would know how much sample remains. And if I said after 15 half-lives, then you would sub a 15 right here, and you would know what percent remains. With me? You okay with it? Okay. We have to label our axes. A graph is only as good as its labels. So what should I put on the x or on the y-axis? What should go on the y-axis here? I've just scribbled all over this thing. It is a hot mess. What should I label that? What did I call it? The 100%, 50%, it's the percent what? It's the percent remaining. So we label our axis percent remaining. And our x-axis. We call it number of half-lives. Half-life is that funny term that simply describes how long it takes for half of the sample to decay. So 1 half-life is how long it takes for half the sample to decay. Now let's see if we can't take it a little bit further. On your whiteboards with your partners, decide if carbon-14, keep your graph because you'll want it. If carbon-14's half-life is 5,000 5,730 years, because it's different for every element. If carbon-14's is 5,730 years, how many years have passed if 2 half-lives have passed? Write it down. If that's the length it takes for 1 half-life, what's it take for 2? Let's see him. Let's see him.
Don't erase because.
I see 3 answers. This is the answer I see overwhelmingly on these boards. 2 half-lives is 11,460. Now, if I told you that 11,460 years have passed, what percentage of carbon-14 would remain? How'd you arrive at that? Half of a half? Did you read your graph? Is that why we left our graph? Okay. You're skill building here. Try this one. Ready, set, go. You can erase it and redraw the graph if you need evidence. Okay, 10 divided by 2. Why did you divide it by 2?
It's like the same, so that would be half of 10, and it's been a full half-life.
So, how many of you evaluated that 5,730 years was in fact 1 half-life? And you're like, okay, if it's 1 half-life, I know based on my graph that half the sample remains, so I divided by 2. We're all with me?
Yeah.
What if, you might want to put your boards down, erase them, and make sure you can speed write. There's your question. How about if it was 11,460 years?
Did you just see it after, what if it was 11,460?
Chad's group, come on down.
Dang it, fast. Dang it.
Sweet.
So,